Hi y'all, I want to talk a little bit about periodic properties today. So what are periodic properties and what is periodic law? So periodic law states that there is a periodic repetition of chemical and physical properties of elements when they are arranged by increasing atomic number. So I'm just going to go ahead and pull all of this up because we've talked a little bit about this, but if you look here, we have periods and we have groups. And the periods move from left to right across your periodic table. So those are the actual rows, which are also the same thing as our energy levels for quantum theory. And then our groups are our columns, and they help us determine some information about the number of valence electrons that each of our groups have. And then I just discussed that. I'm sorry. Please forgive me. Okay, so periodic trends. So we want to look at several periodic trends. Our very first one that we want to look at is called atomic radius. And what we want to explore is what's happening to atomic radius as I'm moving across a period. Okay, so if I'm moving, say, from lithium over to neon, and what's going to happen when I'm moving from something like hydrogen down to cesium. So we want to figure out what are the general properties of atomic radius as we move across these things. So let's look at hydrogen. So hydrogen has one valence electron, and sodium has electrons all the way up to energy level 3, and it also has one valence electron. Now, you can definitely agree that sodium is much larger or greater in size than hydrogen, and that's all directly based on the number of electrons that we must place. So here's hydrogen, and here is sodium, and so sodium will have a greater radius. Okay, sorry about the interruption. So let's look at a few things that are going on here. So atomic radius actually increases as I move down a group from hydrogen through to cesium. My radius becomes larger and larger. One of the issues that's going on here, as I move from lithium to fluorine, for instance, is that effective nuclear charge is becoming greater and greater. So as I add on electrons from lithium through fluorine, what happens is I'm adding electrons to the same energy level, and when I do that, the attractive forces between the protons in the nucleus and the electrons actually get stronger. And so as I move from lithium to fluorine, my size will decrease. All right, so let's go ahead and look at ionic radius. So I love this little picture diagram here. It really helps us to visualize the same thing that we were just discussing before. So ionic radius, what happens to ionic radius as the period number increases? Well, if we look, it becomes greater. Okay, So as I'm adding electrons from this period number down to here, I'm adding electrons in higher and higher energy levels, and therefore my atom has no choice but to become larger. The electron cloud does. Because what's going on again as we're moving down, I'm adding electrons to greater and greater energy levels, and so what happens is that the attractive forces between the nucleus and the electron cloud become weaker as I add electrons into greater energy shells, and so therefore it spreads out a little bit more. Now, what's going on? Again, the same principle with ionic radius as I move from one atom here all the way through to the right side. So my atomic number is increasing across a row. That effective nuclear charge is playing a role again. And so I'm adding electrons into the same energy level, and the more electrons I add, then the more greatly packed that becomes in the electron cloud, because the attractive forces are allowed to be strong. Okay, the last one I want to talk about in our video clip is ionization energy. So ionization energy, there are different levels of ionization energy. You have a first ionization energy, you have a second ionization energy, you have a third, etc. And that is directly related to an electron that's being pulled away. Okay? So basically, the ionization energy is the energy required to move an electron. Depends on how strongly an atom's nucleus holds on to its valence electrons. And there are factors that will affect ionization energy. Number one, nuclear charge, which we've been discussing a little bit. And so what's going on is that the larger our nuclear charge, the greater the ionization energy. So that's saying that the more attracted those electrons are to the nucleus, the harder it is that it's going to be for me to pull those away. All right, we also have what's called a shielding effect. So the shielding effect is where the electrons on the inner shells are inhibiting the ability of the electrons in greater energy levels to be able to hold on to those outer shell electrons. And the radius or the size of that atom will also dictate how easy it is to take away an electron from the outer shell. So the further electrons are from the nucleus, then the less energy it requires to take it from that valence shell. And then, of course, what sublevel are those electrons existing? So anytime we have an electron that's either filling up that sublevel completely, like say 6 electrons in the p sublevel, or 5 electrons that are housed singly in a d sublevel, then the harder it will be for something to remove that electron from that region. All right, we'll discuss the rest of this in class, okay? Thank you. Have a good night.